Welcome to the DIY Honda Garage channel. The DTC P0533 indicates that there is a high voltage detected in the AC pressure sensor circuit of the Honda Civic models from 2016 to 2021. The AC pressure sensor is responsible for measuring the refrigerant pressure in the air conditioning system to ensure it operates efficiently and safely. This sensor typically is located near the AC compressor, connected to the vehicle's powertrain control module, PCM. A failure to read the correct pressure could lead to inadequate cooling or damage to the AC system. It is important to address this issue promptly to maintain the vehicle's comfort and prevent further damage. The Diagnostic Trouble Code flagging in the vehicle system signals the need for thorough troubleshooting to ensure proper network communication and sensor functionality. The AC pressure sensor is a critical component in the air conditioning system. Its primary role is to monitor the refrigerant pressure and send the data to the powertrain control module PCM, allowing the system to make necessary adjustments. Typically, the AC pressure sensor is situated adjacent to the AC compressor, usually near the engine bay. The sensor needs to establish a proper circuit to function effectively. Any high voltage detected may indicate a malfunction. This is essential since inaccurate readings may lead to inefficient cooling operations or possible system failures. The DTC P0533 diagnosis indicates that the AC circuit is experiencing voltage issues, necessitating careful monitoring and troubleshooting of both the sensor itself and its connections. Potential causes for DTC P0533 can range from a faulty AC pressure sensor to poor connections within the circuit. A malfunctioning sensor could send incorrect signals to the PCM, triggering high voltage readings. Any loose or corroded connections at the sensor or PCM may also contribute to erratic voltage delivery. Furthermore, signs of voltage irregularities could stem from wiring issues, including short circuits or open circuits. It's crucial to consider that while high voltage may originate from the sensor, external factors, such as damaged wiring, can exacerbate the problem. Diagnosing the precise source requires a systematic approach to eliminate each possibility while focusing on the integrity of the electrical circuit. Symptoms associated with DTC P0533 can manifest as inadequate cooling performance from the AC system, leading to a less comfortable driving experience. The AC system may also exhibit abnormal behaviors, such as frequent cycling on and off, which indicates it is unable to maintain stable refrigerant pressures. Drivers may also see a warning light on the dashboard, indicating a fault within the AC system. These symptoms point toward the possible malfunction of the AC pressure sensor or its related circuitry, prompting an immediate need for inspection and diagnostic measures. Observing these symptoms can be pivotal in addressing the underlying issues before they escalate into major repairs or replacements. In the first troubleshooting step, the objective is to verify the problem associated with DTC P0533. Begin by starting the engine and allowing it to idle, which ensures that conditions are stable for testing. Once the engine is running, turn on the blower switch, followed by the AC switch. Following this, you will check the parameters using a Honda Diagnostic System, HDS, to verify the reading from the AC pressure sensor. Specifically, you will want to determine whether the voltage exceeds 4.75 volts. If the current condition matches the threshold, it indicates that the failure is duplicated, prompting you to proceed to step 2. If it does not match, you may be dealing with an intermittent failure, necessitating additional inspections of connections and terminals. Step 2 entails determining the potential failure area more precisely. Begin by switching the vehicle to the off-lock mode to ensure safety. Disconnect the AC pressure sensor 3P connector to isolate it from the circuit. Then, utilize a jumper wire to connect terminals A and B on this connector. This bypasses the sensor temporarily. Now, turn the vehicle to the on mode, and once again, check the parameters using the HDS. You should verify if the voltage is still above 4.75 volts. If the condition is confirmed, proceed to step 3. If not, it indicates that the AC pressure sensor is likely defective and should be replaced to restore proper functionality. In step 3, the focus shifts toward examining the SG6 line and its implications. First, you must ensure the vehicle is turned off. Remove the jumper wire previously used and turn the vehicle back to the on mode. With the AC pressure sensor 3P connector disconnected, measure the voltage between the specified test points, test point 1 and test point 2. Test point 1 refers to the AC pressure sensor connector number 1, while test point 2 refers to AC pressure sensor connector number 3. The goal is to find a reading close to 5.0 volts. If this requirement is met, go on to step 4. If not, begin troubleshooting by following the prescribed next steps to ascertain where the failure lies in the circuit or connections. In troubleshooting step 4, the aim is to conduct an open wire check focusing on the PD sensor line. First, switch the vehicle to the off-lock mode to avoid any power running through the system. Utilize the HDS to jump the SCS line and let it sit for at least 1 minute. Following this procedure, you will disconnect the PCM connector A, which contains 50 pins. Next, proceed to check continuity between the specified test points. Test point 1, AC pressure sensor connector number 2, and test point 2, PCM connector A number 33. This tests if the PD sensor wire is intact. If continuity is confirmed, it indicates the wire is functioning correctly, and you should explore authorized service information to continue troubleshooting. If continuity is not confirmed, repair the open wire issue as it indicates a break in the circuit that can impede sensor function. Step 5 aims to verify the integrity of the SG6 line by conducting a similar process to that implemented in Step 4. Begin by ensuring the vehicle is switched to the off-lock mode. Again, utilize the HDS to jump the SCS line, allowing it to sit for over a minute before progressing. Disconnect the PCM connector E, which encompasses 80 pins. Following this, measure the continuity between test point 1, AC pressure sensor connector number 1, and test point 2, PCM connector E number 45. This step is crucial in determining whether the SG6 wire is functioning properly. If continuity is confirmed, the wiring is intact, and you may want to investigate authorized service information for further insight into DTCs. Otherwise, address any open circuits on the SG6 wire to ensure communication between the AC pressure sensor and the PCM is restored. After completing all necessary repairs and ensuring circuit integrity, it's time for final repair verification. Begin by clearing the Diagnostic Trouble Codes, DTCs, from the vehicle's memory using the HDS. This helps reset the system and eliminates previous error flags. Next, perform a thorough test of the AC system functionality to confirm that the repairs implemented have resolved the issues. It is crucial to monitor the system for any abnormal behaviors and to ensure that the air conditioning pressure readings are stable and consistent within normal operating limits. A successful verification indicates that the repairs have restored the system to full functionality. Continue to monitor the vehicle in the following days to catch any recurring symptoms. Preventive maintenance is vital to enhancing the longevity of the AC system and preemptively addressing issues like DTC P0533. Regular inspections of AC components, particularly the pressure sensor and associated wiring, can help catch potential failures before they escalate. It's essential to ensure that all electrical connections remain clean and secure to prevent voltage irregularities. Additionally, periodically testing refrigerant levels in the system can prevent overpressure situations and guarantee optimal performance. This proactive approach not only assists in maintaining a comfortable in-cabin environment, but also helps avoid costly repairs in the long run. Establishing a routine for these checks will fortify your vehicle's AC system. In summary, understanding DTC P0533 and its implications is crucial for maintaining the Honda Civic's AC system functionality. Engaging in systematic troubleshooting helps identify and rectify issues efficiently, ensuring the vehicle remaining operational and comfortable for occupants. Each step, from verifying problems to conducting continuity checks, is pivotal in ascertaining the exact cause of the high-voltage condition in the AC pressure sensor circuit. Regular maintenance checks further complement these efforts, allowing you to keep the AC system in optimal condition and prevent future occurrences of similar DTCs. Committing to these practices not only enhances vehicle performance, but also ensures a safer and more enjoyable driving experience. Please like and subscribe to the channel. See you next time.